Hi, good morning. Now we would like to go through the SLS assignment that you have submitted as your work on planning an experiment. Now let's go through some of the notes given first before we go through the homework, the assignment. Now for planning an experiment, uh, we have to be aware that there are three types of variables: what we change and what we measure and the control variables, at least two or three, at least three key variables to keep constant to make it a fair experiment. Now, in this assignment, I noticed that one of the weakness is uh, there's lack of details in describing how they are being changed, how they are being measured, and how they are being kept constant. So when you get back your assignment through WhatsApp, please compare yours with the model answer given later. Now, what we change, you look at the example, it must be detailed, all right, and how we change. Like example, in this case, uh, we adjust the rheostat so that current is 0.2 ampere. How we measure, read the temperature, all right, necessary calculation, I square, and how we repeat experiment is also important. All right, what variables will be kept constant? Again, please note that superficial control variable is not accepted, like using the same marble in the uh, homework in the SLS assignment is not allowed. It must be something more intellectual, and you have to describe how they are being maintained and the same throughout. All right, so this is 1 mark. Now, what you plot is important. The key idea is to adjust, manipulate the equation into the form of y equal mx plus c. So that because it's a straight line, if the equation is true, and then the gradient will give the constant. But the gradient may not be equal to the constant, unknown constant. You must manipulate. All right, like in this case, the gradient is 3k, and therefore k equal to gradient divided by 3. I may have to play back this video again to get what is the gist of this planning experiment that is 5 marks. Or you can look at the PDF format that attached in the SLS. Part 2, this is the model answer of the solution to the SLS assignment. Now this is a question given around, there are bricks here, and the marble is rolling down. Then there's an angle, and of course the time taken for it to roll from 80 cm to 0 cm is t. Now this is a question which I've just described. Now it's given that g sine q t squared. Now q is the angle here. Because I was unable to type theta, I change it to q. Alright, g sine q t squared equals 1.6. Right, we are supposed to plan a fair experiment to investigate if this is true. Right, so later on you have to manipulate this into y equal mx plus c. Now, where do the 5 marks go to? Now, what we're going to change and how we're going to change? This is important and lacking in the homework being submitted by many of you. And what we're going to measure is 1 mark, so 2 marks. So in this case, we adjust the position of the bricks. Now, if there are too many bricks, we may want to change the number of bricks until Q is 20 degrees. So we may have to change the number of bricks and the position, all right? So that the Q will change correspondingly, all right? All right. Release the marbles from rest, all right? Use the stopwatch to measure the time taken. Now, changing the number of bricks and adjusting the position of bricks so that we can repeat the step 1 and step 2 for Q equals to 25, 30, 35, 40 degrees. All right, you have to repeat at least 4 times so that we have 5 sets of data. All right, so this where the 2 marks go to. Now next, the third mark, What variables and how to hold them constant is important. Right? During the experiment, marble must be always released from rest so that the same initial speed is 0. The marble must roll from the same starting position and for the same length TCM. You must be very detailed in describing and not just putting a short phrase. Alright. I'm surprised and I'm quite disappointed some of you actually score 1 or 0 marks out of 5 marks. That is because you lack detail and you did not describe how. The marble must roll in the same straight path. Alright. So this is important. Now what to calculate? What graph to plot? So for each value of Q, calculate sine Q and 1 over sine Q, which is the inverse, and T squared. So that we plot T squared against sine Q inverse. Now note that you have to manipulate equation into y equal mx plus c format before you can test the equation, because only y equal mx plus c will give you a straight line. If it's a curve, we are unable to conclude whether it's true or not, because there are many types of curve: exponential, alright, quadratic, power curve, alright. So this is another mark, the 4th mark. Now, how to calculate the constant value from the gradient? You have to best fit a straight line, and it's true. Straight line, the gradient will be 1.6 over g, and therefore g will be 1.6 over gradient. So you have to show how the unknown constant is being calculated. All right, this is the manipulation of the equation given into this form, so that this is y, this is the gradient m, this is s, and in this case c is 0. So you see that this is an equation of a straight line. So we plot this as a y-axis. This will be the gradient, and this will be the x-axis. Alright. Now, in this experiment, I forgot to include that we have to repeat twice, repeat once, and get the average over here. Alright. So in order to find the t, here we have to repeat and get the average time t. Alright, because doing one time may not be accurate. Right. So I hope you have understood where the 5 marks come from, and please look through your correction, look through your script that I've marked, and compare it to the model answer. Alright, it's easier to refer to the PDF format that I've sent. So all these slides I've sent in the PDF format. Okay, thank you very much.